Hello everyone, I am Vaishnavi from grade 11, Lake Montfort School. So today I am here to explain you all on periodic classification of elements. So let's start. So the first topic is why do we need to classify elements? As we are aware that there are 118 elements in our periodic table, in which 96 of them are metals, and rest all are non-metals and metalloids. But it would be hard for remembering each and every properties of each and every element. So that to make it easy, we classify them according to the similar properties and uh, make them into groups and periods. So next comes the genesis of periodic classification. So the first one is Dobrynin's triads. So let's know what he did. In each case, he noticed that the middle element of each of the triad had an atomic weight, about halfway between the atomic weights of the other two. So to understand this, let's take this table. So in his table, we can see that these are the element names. The first one is lithium, second one is sodium, next one is potassium. And these are their atomic weights. So what he said is, taking the average of the first and last element gives the atomic weight of the middle element. So let's try it once. 39 plus 7 whole divided by 2 gives 46 by 2, which is nothing but 23. So here we get the atomic weight of sodium. But that he only was able to do for 3 triads. Triads means a group of 3 elements. So he was only able to do for 3 triads and not more than that. So let's go to the next is Newland's law of octaves. He arranged the elements in increasing order of their atomic weights and noted that every eighth element had properties similar to the first element. So here they're telling that Newlands arranged the elements in increasing order of their atomic weights, and he noted that every eighth element had the same properties of the first element. So next is the relation was just like every eighth note that resembles the first in octaves of music. So here they're telling that every eighth element resembled the first element. He used the musical notes to represent these, which are sa, re, ga, ma, pa, da, ni. Sa didn't come again in the last because it has the same properties as the first element. He only could do this method until calcium, as there were cases where he didn't know how to place few elements which had similar properties like cobalt and nickel. So next is Mendeleev's periodic table. Over here, let's see what he tells. Mendeleev arranged elements in horizontal rows, which means are periods in the periodic table, and vertical columns, which means are groups of the table in order of their increasing atomic weights, in such a way that the elements with similar properties occupied the same vertical column or group. So here it is telling the elements which had same properties were in the same column or group. He proposed that some of the elements were still undiscovered and therefore left gaps. He predicted that there would be more elements coming in the future, so he left gaps in the table. He left gaps on, so let's know where he left the gaps. So he left gaps under aluminium, a gap under silicon, and these he named them as Eka aluminium and Eka silicon. Mendeleev predicted not only the existence of gallium and germanium, but also described some of their general physical properties. So when he left gaps for the undiscovered elements, he not only predicted that there will be elements coming, but also he predicted the type of physical property those elements would be having. So let's go to the next one. So now let's learn how to name elements with atomic numbers above 100. So as in the table, periodic table, we know that there are 118 elements. So above 100, there are many elements, like 18 elements are there. So those were named with different names, like each scientist named it with different names. So to have a unique name among all of them, we had given some names to these elements, like all the 18 elements. So let's take an example. Like looking at this table, you can see these are the numbers from 0 to 9 and the names given for that. For 0 it is nil, for 1 it is un, for 2 it is bi, for 3 it is tri, for 4 it is quad, 5 pent, 6 hex, 7 sept, 8 oct, 9 n. So these are the symbols given for these names. So these are the symbols given for these names. So let's take the example of 107. So for 107, the first digit is 1. So 1 is nothing but un. That's why we have taken un. And then 0. 0 is nil. So we have taken nil. And then after that 7 means sept. Here is sept. So it is sept. So the symbol for this will be taken as the first letter of each name. So for 1 it is un. So the first letter of un is u. So that's why we have taken u here. Next is 0. For 0 it is nil. So for nil the first letter is n. So we have taken n as the next letter in the symbol. Next is 7. 7 means sept and the symbol for sept is s. So we have taken as u and s. Now let's take another example. 114. So 1 means un as we have seen it earlier. So un. And the symbol it is u. And again 1 has come, so it is un again. And the symbol is again u. Now 4. 4 is quad. Quad. And the symbol is q. So we have taken quad and q. So it becomes un quad. Next one is 110. 110 over here again there are two ones. So it will be un. And for 0 it is nil. So nil. And the symbol for 1 is u and u. And for 0 it is nil. So it is n. So I hope you understand. And I would like you guys to try this example. I'll give you one. So it is 109. Yeah. So I would like you all to solve this one. Hope you all understand this concept, and if any doubt, please let me know. Thank you.